In this video, we're going to have a look at acceleration in physics. We're going to look at its definition in an example problem. And we're going to look at the fact that it's a vector, that it has direction, that it matters which way you're going and which way you're accelerating. That's today on High Peak Education. So thanks everybody for joining us. In today's problem, we're going to take a look at acceleration, its definition on a one-dimensional axis for a particular problem. And that's coming at you right now.
Here we have a problem which helps us to understand acceleration. It says a train is 5.25 kilometers from a train station, moving at the constant speed. 3.0 minutes later, the train is 3.75 kilometers from the train station. What is the velocity? The train comes to a stop from that velocity in 20 seconds. What is the average acceleration in meters per second squared? Well, let's perform part A. So we know that this position right here, that's calling it x1, is 5,250 meters from the train station. This final position 2 is 3,750 meters. That's just converting kilometers to meters using SI units and metric conversion. We also know that 3 minutes, again converted, so I think there's 60 seconds in a minute, that would be 180 seconds. We want to know what's its velocity. In part A, the velocity, which is a constant in this case, is going to be the change in position over the change in time. The change in position is going to be the final position, x2 minus x1 over delta t. And we know what x2 is. That's 3,750 meters minus the initial position was 5,250 meters over the time change, which was 180 seconds. So let us calculate this. So 3,750 minus 5,250, and we'll divide that all by 180. So we get about negative 8.33 to 3 significant digits, negative 8.33 meters per second. Now it's negative because the train is going to the left. The x-axis is to the right, the positive x-axis. So the train is going to the left, so its final position is smaller than the initial position, so we end up with a negative velocity. Furthermore, this is its speed, 8.33 meters per second, but its velocity in the x direction is signed, S-I-G-N-E-D. In other words, it has a direction. So from that speed, the train comes to a stop in 20 seconds. What's the average acceleration in meters per second squared? If we want the acceleration in the x direction, that's the change in velocity over the change in time. We know that the change in velocity is going to be v final minus v initial. And the time was given, that's going to be 20 seconds. It comes to a stop, so v final is 0 meters per second. The initial velocity is this, negative, so we do minus negative 8.33 meters per second. And we divide that by 20 seconds. So 20 seconds. So let's get this acceleration, 0 minus negative 8.33, and we'll divide that by 20. Okay, so we've got 4.4165. So let's round that to 3 significant digits, 0.417 meters per second squared. Notice it's positive. It's positive because if the velocity is becoming more and more negative, then we would have a negative acceleration. But since that negative velocity is becoming closer to 0, there's a positive acceleration. That is to say, slowing down a negative velocity is the same thing as a positive acceleration. The velocity vector is to the left, the acceleration vector is to the right. That causes the train to slow down. All right, so hopefully you understand acceleration better from this problem.
So what we saw in this acceleration problem is that we need to use the definition, the change in velocity over the change in time. Furthermore, the acceleration can be positive if we're slowing down a negative velocity. That is, if the acceleration is in the positive x-axis direction, that can be due to the final velocity being a smaller magnitude, but the initial velocity being a larger magnitude, but then let's say either both being negative or the second one being zero. But either way, the acceleration ends up being positive because, again, acceleration is a vector. It has a direction. So a positive acceleration comes about because a negative acceleration becomes less and less negative. So I hope that makes sense to you. Let us know in the comments how you're going to use this in your physics classes. And thank you for watching High Peak Education. Please smash that like button if you enjoy this content. Social media links are down in the description box below. Please support the channel to grow the channel. And thank you for your attention. We will see you in the next video.